Got a bit of a neat device to look at today. This is a call display device that goes back probably 20 odd years that I've had this thing. I haven't used it in a while because it's acting up. So today I figured we'd take it apart and see whether I could do anything to get this thing to work. So let's check it out. Well, in case you guys haven't noticed, my bench is actually looking a little bit bigger today than it has for a while, and that's because, well, besides cleaning off the desktop a bit, and I don't mean I just pushed everything to the back, I actually cleaned up most of the stuff at the back too, but my scope and stuff, I was noticing my scope seemed to be getting closer and closer and closer to the front of the bench, and it was actually up to about here, and that's because I had a speaker sitting on top of it before. And the speaker that was there is now gone. I put the speaker actually on top of the monitor. So what was happening was the weight of the speaker pushing against the scope and lying up against the wall was slowly, over time, pushing everything forward. So as you can see, I actually have a lot more room to work now with things back the way they should be. I got a few things I still got to go through here, put away tapes and so forth, but ultimately, I've got a little more room now to work on the workbench. And today we're going to look at this gadget here. This gadget is a call display device. Now, basically, the premise of this is it works off the persistence of vision, like that propeller clock, and like the wand clock that the wand swings back and forth and displays the time by flashing a series of LEDs, which, through the persistence of vision, gives you the effect of putting letters and numbers that appear to be in midair. This works off the same principle. This is a rotating device. It has a series of LEDs that, as it spins, the LEDs here are able to form letters and numbers, and it makes it look like they're floating around in this ball. And this is something I've had for a long time, and it stopped working. It started displaying random characters, so I took it out of service. Let's see if we can get this thing to actually display the correct information today. A quick peek at the bottom says it requires 9 volts at 300 milliamps, and it's tip positive. So I've set up my power supply with a 9 volt plug on the end, tip positive, and I have verified the polarity. So if I plug this thing in, you'll see that it'll start to spin, and it's probably going to start to spit out random, if anything. There we go. Hey, it's actually displaying something. Holds 54 caller ID records. Is this thing actually going to work? Oh, maybe not. Well, maybe it will. Who knows? Maybe it was my... Oh, look, it's even got my company on there. That's the last time I used this thing. Is this thing actually going to work? Maybe it is. It wasn't working before, but maybe the adapter was the problem. There are 26 new records in the call log. It's kind of neat because the thing just seems to rotate around forever, but this thing's actually working. As I say, the last time I turned this thing on, it did not work at all. Caller ID list. Erase messages. Set off on time. Set messages. Set daylight saving time. Set date format. Okay. Set time mode. What's it going to do here? See if I can actually okay, it's displaying the last time it got a message from here came from Shoppers Drug Mart, 2503-2001. Now maybe we're going to start seeing some of the errors. Yeah, see, it missed the letter there. See, there was letters missing. In call, supposed to be call, there's missing L. So what's happening is it's for some reason not transferring the data from the base unit to the actual spinning propeller that's under this dome. And sometimes it doesn't show the right information. There are 25 new cells in the. This is where the problem. This is what it was doing. This is what I took it out of service for, and I don't know why it's causing it. It could be the motor is wearing out. The battery low, duh. But it still remembered, no battery in it. But it still remembered the numbers that were stored in it. This thing here transfers the information. We'll take it apart and take a look at this thing. See what makes this thing tick. But this unit transfers the information optically. So there's a transmitter in the base, and then it transfers the information up to the display. And there's only LEDs in one side. This one here is just here as a counterweight. There's only LEDs on one side of it. To open this unit up, there should be a couple screws in the bottom here, which I can remove. Probably only a couple screws left because it's been apart before, but we'll take out the screws. If you wonder what happened to my hand here, I was looking to see which of my markers still had ink in them. I was testing it on myself to see which Sharpies had ink and which ones could go in the garbage. Okay, there's the top off. Here's the unit that spins, and this bottom piece should lift out of here too. There we go. There's the bottom. Take out the. Oh yeah, there is a safety switch in here too, so that if you were to open it up while it's running, it would shut the power off for obvious reasons. So they've got a tamper switch on the unit to prevent it from spinning if the unit's not together. So let's just remove that switch so that I can get the base completely out of the way. That out of the way. It's got a little weight in the base too, so that it doesn't shake and vibrate all over the table. At least I've done the motor right. It's got looks like a BSL motor that they've put on here. My other one, the propeller clock that I built, well, the reason it doesn't work so much or well anymore is because the motor that they put on it did not last. So we'll take off the oh, that screw looks different than the other two. I should mark this which way it's coming off too. Oh, it already did. There's a little dot there to indicate which way it goes, because obviously putting this thing on the wrong way is going to be a problem. Okay, here's the unit itself, and as you can see, in the base there are two slip rings. It makes contact with right here. And the other one, I'm looking for where the other one is. I guess it must be through center shaft. There's two contacts on here. But where's that second? Oh, there it is. There. Well, maybe that's the problem. Maybe that second contact had come loose. Oh, you know what? I think the center contact, this one, okay, wait a minute. This just sits on top here, like this. This sits on top of this and provides power from this center post over to the contact on here. So this is maybe where the problem is. It may be, as it's spinning, it may be losing its connection. I'm going to use some deoxit, and we'll put a bit of deoxit onto these contacts first of all, just to make sure that the connection there is good. Looks like there's good torque on. There's little springs here with brushes on them, and it looks like there's, well, that one's kind of loose. This one feels to be tighter than this one. But that's what I'm thinking. I'm thinking that the reason why this thing is not working properly is because possibly there's an intermittent loss of power as it's transferring the data. You see, there's a little LED emitter right here, and this LED emitter sends the information that gets sent up to this little receiver. The little receiver then sends the information over to the controller chip, which is spinning along with everything else. There's actually another little LED, or this would be another receiving diode, and what that one does is there should be a second one in here, which there is. There's a second LED right here that's got this shield around it. What happens is, as this thing spins, every time this LED, or this should say, every time this photo detector passes over this LED, it picks up a pulse. So that way it tells the timing circuit where it is as it's spinning. This is very important. If this were to get dirty, you wouldn't get proper communication and it wouldn't be working properly. It looks like there's a fair bit of dirt in here just from the years that it's been around. We'll clean that up. This one here, the way that this one here is positioned with this shroud around it, this one here will actually fire the information out like this to be detected by this one, which is running around in the middle here. It's spinning around in the middle. So this one's going to detect that information, the data, and this one here is going to detect the position of the rotor as it's spinning. Positive and negative is marked right there. One of these is going to be positive and then the other one's negative. And if we check it with the meter, we'll see that one of them, the negative one, this one, should come up on here. Well, it's not coming up as well as I thought it would. This one's positive. Positive, not perfect, and negative. Let's clean those. Let's clean those posts. Clean the slip rings down here, and maybe try adjusting the tension a bit, and then put this thing back together and see whether it actually performs any better than it has been. So we'll clean the LEDs and the photo receivers first with some isopropanol. Make sure that there's no dirt on those. Clean our contacts off a bit here. Same with this one. Now get the deoxit out and we'll put the deoxit onto these contacts and the slip rings. And I think I can be able to adjust. I don't know if I can adjust it by... I guess I can't because they're glued in place and there's a locating pin, so that probably does not affect the you don't want it too high to torque anyway, because if there's too much tension it's just going to wear the brushes down. It does have brush on each end. So we'll give a drop of deoxit to the slip rings here. One there. And one down here. And just rotate this a bit. We'll put some deoxit on the contacts here that receive the power, and again here and here, and of course on the other contact, this one. This might be the hard part, getting this to go back together. Get my fingers out of the way. I'm going to operate the little switch, otherwise I could lose a few digits. It's not displaying anything. I mustn't have proper power. Oh, there it goes. Hold on. Yeah, it's still missing characters. It's now really missing characters. One thing I've noticed is it may not be centered. Watch it as it's rotating. It seems like it's doing this. If I turn it more like this, you can probably see it better. See? That might be part of the reason it's not balanced. So let's see if we can balance this a little better. If we turn on night shot, you can actually see the infrared LED here. The other one won't start to send any information until it's up to speed. If I turn on the switch, you'll see it spins. The other one's not going to pulse anything though, I don't think. Maybe it will. It might, because it doesn't actually provide any feedback. So we might actually see the other one start to pulse information. There we go. There was the pulse of information to tell it what to display. And something is causing interference or causing that data to not be retrieved. Watch it again. You'll just see a quick burst. That's what sends the information to the other microcontroller. This one just sends a constant reference that is detected and is used to synchronize the processor, and then it receives the payload from this one, which displays the message. So somewhere between the transmission of the information, either the information's corrupted, which I don't think it is. I think it's somewhere along the line as this thing's spinning, it sends that blast of information, and that information is being corrupted somehow. I'm curious, these capacitors that are on here, whether they're maybe going bad and we're not getting good DC. Because of course, through the slip rings, you're not going to get a perfect signal. Maybe, just maybe, one of these capacitors is going a bit weak, and we're not getting good DC, and we're getting corruption. So let's just pull out the ESR meter, and we'll look at these caps and see whether the caps themselves are going bad. 10 volt, 220 microfarad, and what's the other one? I think they're probably the same. 10 volt, 220. So these are both 220 at 10 volt. So 220 at 10 volt should be no worse than 0.6. So let's just see what they are. We'll just short them out first of all to make sure that there's no charge in them. And what is my ESR? 0.5. And 0.7. Well, 0.5. And a new one should be no worse than 0.6. So these are probably not the problem. If I look at a couple new ones, these are the same rating, 0.45, 0.43. So they are a little bit better than these ones, which are measuring up again at, what were these ones? 0.52 and 0.52. So I can't see them being the problem. I do have a couple of 10 volt 220 electrolytic caps that I can certainly put in just to see whether it makes any difference. I don't see this being the problem, but because I've got a couple small ones here, why not? Why not do it just to try it? It's interesting that neither one of these were glued down to the board. But there's the two new ones are on there. I guess we can try this again and see whether it makes any difference. Power. Don't think so. Looking exactly the same as it did before. Other than the fact that it now feels to be more unbalanced than before. If you look on the bottom of the board here, you'll see solder on here. This is actually to add weight to balance it. When they put these things together at the factory, they would have spun this up on a balancing machine and added lead basically to affect the weight and affect the balance of the unit itself. So changing out these capacitors made no difference whatsoever, but it did certainly affect the balance of it because the new ones are smaller. So I'm going to put the original ones back in because these aren't making any difference other than make the thing even more unbalanced than it originally was. So fortunately they're pretty easy to take out. Just heat them up and remove them, and the other one's still got all the solder and everything on it, and they go in the same way. One goes in one way and one goes in the other, but the board is marked. So that one goes there. Yeah, it's much better. Much better. The other one was like it was, you could feel the thing vibrating. So just the weight of those capacitors was different. Actually, I don't see any errors in it now. Did I fix it? I'm going to put this thing together. I'll take out the screws and just see whether it does lift away. I don't think it does, but let's just see if it lifts away or not. Oh, it does. Okay. Oh, the motor wires are down here. Okay, that's where that is. It does appear to be it is a BSL motor, but the drive circuitry for the motor is actually right in here. You can see it. So it's just feeding it DC, and the motor drive circuit is there. I could probably take this motor off of this thing and use it to power up my other little propeller clock. Be a little more reliable than the motor that's on it. But here's the ICs here that control this thing. As you can see, this one here is coated in epoxy. You just got a regular conventional IC over here. Little microprocessor of some type. Here are the two LEDs that send information. One of them is just showing or shining a constant. One of them just shining a constant light source to synchronize, and the other one is the one that blasts the data, and that's this one here. I can tell by the positioning where they go into the board. The one closest to the motor is this one, and that's the one that sends the data. It's fed off of this chip right here. So that's the proprietary chip. It's sending out the payload to be decoded. It's probably a pretty common chip too that they've got on here. And they've done it this way to keep the number of the IC secret. Or they may have just put the silicon wafer right onto the board, and the bonding wires go right to the traces, and then they encapsulate it. But that was quite a common way of trying to protect your intellectual property back in the day when there were so many things that were being copied. You made a product and you either sanded off the numbers or you encapsulated it in such a way that it made getting information impossible without destroying the chip. Because so many companies would, I'm not pointing fingers at any countries, but so many companies in various countries would copy other companies' designs and market them themselves. That's that little unit. We're going to put this one back together, and hopefully it'll still work when I get it back together. As I say, these things are not that common now. They used to sell this at Radio Shack, if anybody remembers Radio Shack. I'm sure that's where this came from. You used to always get all kinds of neat little gadgets at Radio Shack, going back over the years. It wasn't a place that I shopped at every day for sure, but every so often I would go in there and just see what they had. And as I say, sometimes they had some neat little gadgets, and I would pick them up. One of them was the pin clock. You guys have seen the pin clock. That was one gadget that they sold. This was another gadget that Radio Shack sold. Goes in like that. Somehow like that, and then the top cover drops in place, and it's the top cover that activates the lockout switch. Little tab here on the lockout cover is what activates that switch. So that way, I guess the whole idea behind the lockout switch was if it got dropped and broken, that it would stop spinning. Seems to be working. Yeah, these are loud when they're running. But yeah, it seems to be working. It also displays the time, but obviously the time is not set on it yet because it hasn't been, like it's not plugged into a phone line. When you plug into a phone line, the first time it receives a call, it will display the number, and that will set the clock. So I'm going to phone it and see whether it will display the time. Yep. That's displaying my number. And yes, guys, that is a real phone number. That is one of my phone numbers. If you phone it, this phone will ring, but I won't necessarily answer it. Now it's got the right time on it. That's how the time gets set. This bloody thing is working. It just seemed to want to come apart and have some contacts cleaned on it because now it's displaying the right data. Interesting. Thanks for watching. We'll catch you again in the next one real soon. Neat gadget. I might actually have to put this thing back in service. If it's going to keep displaying the right information, I'm going to keep it in service. See, normally it displays the time. Which is kind of neat. And it says there are 23 new calls in the call log. One new call, the other ones are old. Anyway, thanks for watching. This thing actually seems to be working now. We'll catch you in the next one. Bye for now.